Hello friends, today we will discuss about Edge AI. Edge AI is bringing your AI model on your local device itself. So this AI model act as a brain in your device. So in this video we will see what Edge AI is, why it's so trendy now, and how to decide whether to choose Edge AI or Cloud AI application, then the hardware that is needed on the physical device where we want to run Edge AI application, then we will discuss about the software part, then we will discuss about the compressing techniques through which we can compress the AI model, then we will discuss on safeguarding the data on the local device, and lastly I will demonstrate you with a Java application which is a executable jar having AI model bundled inside, which we can install on edge on a local device, so it will have AI running on the local device. So it will be a practical demo of one application which act as edge AI application. So let's start. So as we know, we don't need internet for unlocking our phone. We can unlock our phone even when there is no internet. This is because there is some intelligence on our phone that authenticates the user. Similarly, Edge AI means bringing the AI model on your phone, on your local device, on your IoT sensors, so that they can process the data that is generated by your device. So in cloud AI, whatever data is generated by your IoT devices or your smartphones, those data will be transmitted to cloud AI. Their AI model process that data, and then user sees the response. So there is a network which is required. Whereas in Edge AI, the source where data is getting generated, at the same source we will process that data itself, so user will get the instant response. So processing happens locally on your local device. If we compare Edge AI with Cloud AI, benefits of Edge AI are privacy because data remains on the device itself, then low latency because there is no network required, AI model is on the device itself, and since AI model is on the local device, so it will work in offline mode as well, no internet connection required. Whereas if we talk about the benefits of applications running on cloud AI, there we will in cloud AI we will get high computation, because cloud infra is providing uh, good infrastructure, powerful infrastructure. So if my application requires high computation, I will opt for cloud AI platform. Also in cloud AI I will get like scalability because infra is unlimited over there. The challenges in Edge AI are power limit because battery is limited, then limited processing power, limited storage space because our local device have limited resources. Whereas if we talk about challenges in cloud AI application, uh, it is latency because data will be transmitted from your device to cloud, so there can be network latency, and also we need internet access for cloud AI application. If we see where we can have Edge AI application installed, we can have these application on smartphones. Like smartphone will be bundled with the AI model and respond to user query faster. Similarly, driverless cars, where sensors generate the data and AI model will process it instantly. Industrial cameras, traffic system, fitness wearables. These are uh, some of the devices where we can have think of Edge AI applications, and there are a lot more. In fact, these are just the example. So why Edge AI is so trend in these days? This is because with IoT devices, with wearable fitness trackers, with our smartphones, we are generating gigabytes of data, and this huge amount of data we cannot transmit all of that on cloud platforms. So so the good thing is that because it will be costlier to transmit all data to cloud platform, instead of going to cloud, we bring the intelligence from cloud to local device itself. So data that is generated on these devices will be processed on those devices itself. There is no need of transmitting this huge amount of data to cloud. So so edge AI is the solution through which we can process this huge amount of data locally on the device. So yes, these are the driving factors for edge AI application. Like if I want my application to work offline, if I want immediate response from my application, and if I want data privacy, then I will opt for edge AI application, because since data is there on the device itself, there is no pressure of GDPR guidelines or HIPAA guidelines, because data remains on the device itself. So how can I choose while developing an app that whether I should use Edge AI or Cloud AI? These are the four factors. If I answer them, then I will be able to better decide whether to choose Cloud AI solution or Edge AI solution. These factors are data sensitivity. Can the data leave the device? Number two is compute need. That means how much power is required. Number third is latency. That means how fast must the response be. Number four is scalability. That means how big does this need to get. So based upon these four factors, I can choose whether I should opt for Edge AI or Cloud AI application. If I talk about the hardware that is required to run Edge AI application, so hardware must have GPUs, because GPUs can process thousands of parallel operations. Hardware must also can have TPUs, because TPUs process tensor operation fastly. Hardwares can have NPUs. Hardwares also have some passive cooling mechanism and thermal throttling, because for high computation a device may get heat up. So the hardware of edge AI application should include some cooling mechanism. If I talk about the softwares that are required for edge AI application, like Google has TensorFlow Lite, where we can deploy the ML models on edge devices using TensorFlow Lite. Model will be trained on the cloud, and it can be deployed on the edge device using TensorFlow Lite. Similarly, we can have ONNX Runtime, which is from Microsoft. It offers cross-platform inference. That means run model from any framework, anywhere, with maximum performance. This means my AI model can be developed using PyTorch in Python, and can be used in an application that is developed in Java supporting cross-platform, this ONNX Runtime. Third is OpenVino. OpenVino is designed to optimize and deploy deep learning models efficiently on Intel hardware. So I will demonstrate on this ONNX Runtime. I developed one application using ONNX Runtime, one Edge AI application. So I will demonstrate at end of this lecture. So we learned about that in Edge AI we bring the AI model on the device itself, not going for cloud. But how a vast, huge AI model can be settled in a small hardware. This is possible by compressing that AI model. There are few techniques to compress the AI model so that it can fit to the edge devices. First technique is quantization, and quantization reduces the precision of numbers weight in a neural network to make them smaller and faster. As we know, neural networks use numbers to make predictions. Normally these numbers are 32-bit floats, which are precise but take a lot of memory and computation. Quantization reduces the precision of these numbers to smaller formats. Say in this image, if my weight is 123.4567, this value, if I need to store in memory, I need to define it in a 32-bit float, which will take more memory. Instead, I can round off it to integer only, 8-bit integer, that is 1 to 3. So this way I need less memory. So this technique, although both the values are accurate, 1 to 3 is also accurate, and 1 to 3.4567 also is accurate, although decimal value is more precise, but without decimal also I can get accurate decisions. So this way I can reduce the size of the AI model by reducing this precision, and this is very famous technique in shrinking the AI model. Next technique is pruning. Pruning is the process of removing weak or unnecessary connections in a neural network to make it lighter. Like, not all neurons and weights in a network are equally important. Some barely contribute to the output. Pruning removes these weak connections. So that means if on a tree we have several branches, few of them are giving fruit and few of them are not having fruit, so we can cut those branches which are not giving the fruit. This way we can make the tree smaller. Similarly, in AI world, by removing those weak neurons which are not contributing to the output, we can reduce the size of the AI model. So this compressing technique is also very popular, pruning. Next technique is knowledge distillation. That means if the requirement is only, say for example, to check temperature, BP and weight of a patient, a doctor can do that, but also compounder can also do that. Like, doctor can train a compounder for these small works and save his time, and compounder can perform like checking your BP, temperature, weight. This technique is like calling knowledge distillation. Similarly, a powerful AI model will train a small AI model to perform the routine work, and this technique is also helpful in shrinking the size of the AI model. Example, Gemini is training Gemini Nano AI model. So this way. Now, as we are saying, everything is on the device itself. AI models is also on the device, and data is also getting generated on the local device itself. So we need to safeguard the data, and for that we use encryption. Even we can use homomorphic encryption in our edge devices to safeguard the data. Like in this image, if you can see, normal encryption is like encrypting the data. That means putting that data in a, say, locker, and then if anything we need to change in that data, we first need to decrypt that data. That means we need to open this locker, take the data out, do some computation, then again encrypt it back, means put it back to the locker and lock that. This encryption method may have risk because we during computation are decrypting the data and then later after computation encrypting it back. Whereas in homomorphic encryption it says that you don't need to decrypt your encrypted data, you can perform computation on the encrypted data itself. That means without opening this locker I can take the data and do some computation. Like, without opening this locker means without encrypting the data, I can perform the computation and keep my data protected inside the locker, because locker is never opened. That means data is never decrypted. In locked system itself, in encrypted system itself, computation is performed. So this is example of homomorphic encryption. So we can do that also on edge devices where data is getting generated. Now lastly, in this video I want to show you one demo where I developed one executable jar which is using ONNX Runtime, and this way this jar is like a demo for your edge AI application. That means my edge device where I want this edge AI application to run, that device need only to have Java runtime, and if I place this jar on that Java runtime on that local device, then it will work as edge AI application. So Say for example, if I want to install this object detection application, which is detecting objects in an image. If I want to install that in a camera, then my camera only needs to have Java runtime, so that it can process Java application. And I will just place my this executable jar on the hardware, on the storage of this camera device, and it will work, and it will run the AI model locally without internet, offline access. And let's see how I can do that. So let me demonstrate you one app. I developed one Edge AI demo application. This application uses a local AI model, and it basically detects the objects in the uploaded image. I prepared this executable jar, so user just need to run this command java-jar, then the jar name and the image that user wants to upload. So if I show you this image one is cat, as you can see, and image 2 is a dog. So if I run this executable jar, which is having AI model bundled inside it, so let's see the output. So it is processing the image 1, and as we know, image 1 is cat, so the object is detected correctly. It is saying that it is a cat in the image. And if I say go to this and change it to image 2, which is a dog, then it is processing this image, detecting that the object in the image is dog. So this executable jar I developed in Java, and I used ONNX Runtime. ONNX, as we know, Microsoft Open Neural Network Exchange format, which says that you can use the AI model in ONNX form, which is a lightweight AI model. So let me explain you about this project. So this is a Gradle project. I am downloading two dependencies. One is ONNX Runtime. Like for Java code, we need Java runtime. So similarly for AI model which are in ONNX format, we need ONNX runtime so that it can understand and run those AI models locally. And second plugin, that third-party library that I am using is OpenCV. This jar converts the uploaded image to a floating array number. As we know, in AI, the AI model uses numbers to calculate weight and predictions. So this jar is converting the image to a floating array, and this jar is using the AI model to detect what object is there in the image. Only these two dependencies are needed for this object detection application, edge application. So this application can work in offline mode as well, because AI model is in the jar itself. If I show you the jar structure, just a second. So this is my executable jar, which is of 206 MB size. And if we see what's bundled inside, we can see that we have a AI model. This AI model, MobileNet V2, I downloaded from ONNX Model Zoo. It is a vision AI model that is used to detect the objects in the image. So this jar is basically having AI model inside it, and then my Java program. So if I show you the Java program, it is also very simple. Here in Java, we just need to register the AI model in ONNX classifier as the first step. Then we need to process the image to convert it to floating array. I told you that I am using this OpenCV jar to convert this image that is uploaded by user to a floating array. Then there is a classify method in ONNX classifier that will help detect which object it is containing in the image. So just in 4-5 steps or small short lines of code, I am able to uh, uh, like detect the objects in the image. So the primary goal of this application is to demonstrate you that yes, in executable jar also we can bundle our AI models. We can download the AI models from Hugging Face in ONNX format. Like you can see, there are a lot of models over here which we can download, which are ONNX, which are here in ONNX Model Zoo. And also there is a website like onnx.ai. Here you can simply download these LLMs directly on your local system. And hence, to develop say a edge AI application, what I need in the device, I just need Java to be installed on the device where I can run Java runtime environment, and then I will place this executable jar on that device and trigger the command on some event, and it will run on your edge local device. So response is fast because AI model is in the device itself, and no network connection is needed because AI model is not in the cloud, it is in the device. So this is the practical application where I am demonstrating that how easy we can talk to LLMs from our local device, and also we can have AI models on our local system. We just need to like have ONNX runtime uh, and ONNX AI model in ONNX format to run those AI models, and that's it. Like there is another way also through which we can talk to the LLMs, which is using Olama. Like in Gradle we can download third-party libraries to our local system by using Gradle. Similarly, using Olama we can download the AI models on our local system, and then using Spring AI we can communicate with these AI models that are downloaded locally in Olama using Olama API and Spring API. So that is the second approach that I will cover in the next video. And this approach, the first approach that I showed in this video is talking to LLM locally using ONNX Runtime. I hope this is cleared. So I will share the GitHub URL of this project as well in the comments. Thank you for watching. Please subscribe to my channel.